Hello everyone, I am Kim Changmin from the Department of Computer Science. Weeong, 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 weeong. When an alarm sounds in a nuclear power plant, engineers don't panic. They just follow manuals step by step. Let's apply that idea to bad habits. If we could follow a clear manual when those impulses arise, maybe we could handle them more effectively. Based on this idea, I developed an application, and today I'll talk about its engineering design. You can download the application here. Here's how it works. First, the user selects their current emotional state, like lonely or stressful. Then the system generates a simple micro mission relevant to that situation. Finally, the user reports the result, failure or success. Now let's look at the overall blueprint of our system. This slide shows the fundamental structure of our app. The first problem we had to solve was data inconsistency. To solve this, we designed our game data manager using the singleton pattern. In simple terms, the singleton pattern is a rule that establishes only one central authority for the entire system. It's like trying to control one TV with multiple remotes. It can create confusion, right? So instead, we enforce the use of just one official remote. This is exactly why in our app, the gold on the main screen and the gold in the shop are always displaying consistently. It's because only one official source of data exists. It ensures data integrity. In this part, the problem was how should the UI react instantly when the data changes? If the core logic of our application had to be directly responsible for updating every single visual element on the screen, our code would become tangled and messed, making it impossible to maintain. We solve this with an event-driven system using the observer pattern. It's similar to a YouTube subscription model. Like a YouTube channel, the data manager simply broadcasts a signal that data is changed without caring who is subscribed. You can see it in action here. When a mission is completed, a data changed signal is sent just once, and the experienced bar, as you can see, which was subscribing to the signal, instantly updates itself to a latest state. The key benefit of this design is decoupling. Because the data logic and the UI logic are not dependent on each other, we can add new UI element in the future without ever modifying the existing core code, which making it highly extensible. Next, a user's hard-earned progress must never be lost, even if the app closes. To ensure data persistence, we chose JSON serialization. When the app closes, the entire player data object is converted into a blueprint in a text-based format called JSON and saved as a file. As you can see, all the data remains the same. When the app launches again, it reads the saved blueprint and restores the object. Internally, each member variables of the player object is serialized into key value text data and reconstructed later, ensuring precise reconstruction of all states. Now I'll talk about object-oriented design. Singleton and the observer pattern were part of it. Our problem was simple. How can one use button handle many different items? The easy but messy way would be to write giant if-else statement like this. If the item is positioned here, if it's a scroll, gain experience point. But with this approach, we would have to change the button's code every time we add a new item. That's not a good design. The idea is best explained with a barcode. If the messy if-else approach is like a cashier who has to memorize the price of every single item, when a new product comes in, you have to update their memory. It's slow and risky. Our design is a barcode. The cashier's job is simple, just scan. The item itself holds all the information. Our use button is the simple scanner. They just scans the item and the item knows exactly what effect you run. First, we create a rule, an interface called iUsable. It simply says that any tool object must have a use button. The tool then we made separate classes for each tool, like heal effect and the gain experience effect. Both follow the iUsable rule. Former use button is wired to heal the player, and the latter to give the player experience points. Finally, when we create a heal potion, we put the heal effect tool in its hand. When we create an experience score, we give it the gain experience effect tool. Even if we were always calling the same exact use method, mm, use method, the result is completely different. Uh, We overcame our technical challenges using four major design patterns. Singleton pattern ensured data integrity by centralizing control. Observer pattern built an event-driven UI for real-time updates and scalability. JSON serialization uh, achieved secure and persistent data storage. Strategy pattern designed a flexible module item system for future expansion. Looking ahead, I plan to enhance the user experience with more engaging quests and variety of new Shiba skins, and interactive features where the character reacts to the user's touch like this. Uh, Thank you for listening.